In the middle of Israel's dry Negev desert, where daytime temperatures can become extremely high, rainfall is limited, and natural freshwater is scarce, vast greenhouse complexes stretch all the way toward the horizon. This is the Arava Valley, one of the driest areas in the Negev desert. From above, it looks like an agricultural city built in the middle of a lifeless landscape. Inside, these enormous greenhouses are vegetable farms, fruit crops, and most importantly, endless rows of healthy tomato plants. To make this possible, Israel did not wait for rain. It built large seawater desalination plants, advanced water treatment systems, and an extensive network of pipelines capable of carrying water into extremely dry regions. Every drop is then delivered directly to the roots of the plants through precise drip irrigation systems. Alongside the water infrastructure are solar farms, pumping stations, sensors, automated controls, and operating centers that work continuously. Areas that once seemed unsuitable for large-scale agriculture have now become advanced food production zones. Israel did not try to defeat the desert with human labor alone. It created an integrated system capable of controlling water, energy, temperature, nutrients, and every stage of agricultural production. And before we continue, take a moment to look at this landscape and ask yourself, if this dry valley can become a major food-producing region, what other places in the world could be transformed with the right technology? The journey of an Arava tomato begins here. Every successful harvest begins with a seed. At modern seedling centers, tomato seeds enter a production line that is almost entirely automated. First, growing trays move onto a conveyor system. Machines fill each small cell with a carefully prepared growing medium, press the surface, and create planting holes at a consistent depth. Individual seeds are then placed precisely into position. The system covers them with a thin layer of material, adds moisture, and transports the trays into controlled germination rooms. During this stage, temperature, humidity, light, and water are monitored continuously. If the temperature is too low, germination slows down. If the humidity is too high, disease can develop. If the lighting is not properly controlled, young plants can become weak or grow unevenly. Every environmental condition must therefore remain within a carefully calculated range. But in the Arava Valley, producing a strong tomato plant requires more than simply germinating a seed. The environment is too demanding. Plants must tolerate high temperatures, saline conditions, disease pressure, and repeated production cycles. For this reason, many tomato plants are produced through grafting. A variety with a powerful root system and strong resistance is selected as the rootstock. The upper section comes from a tomato variety, chosen for fruit quality, yield, flavor, shape, or market demand. Machines assist in cutting the young stems at a precise angle and height. The upper and lower sections must be compatible in size so that their tissues can reconnect. The two pieces are joined with a small grafting clip. Even a slight error can prevent the graft from healing correctly or cause the plant to develop poorly. After grafting, the plants are moved into a recovery chamber with carefully controlled humidity, temperature, and light. During the first few days, the young plants need time for the tissues to reconnect. Once the graft has healed, the plant begins growing as one complete organism. The powerful root system provides resistance and stability, while the upper variety produces tomatoes with the desired quality and yield. This is not simply a plant growing process. It is biological engineering designed for the desert. If you are impressed by the precision behind such a small seedling, comment below with the word technology, because the next stages show how this precision continues across the entire farm. After grafting, the young plants continue growing inside the nursery. The trays move through inspection areas where every plant is evaluated. Seedlings that are too small, weak, bent, damaged, or developing abnormally are removed. Only plants with strong roots, straight stems, healthy leaves, and stable graft unions are selected. The accepted seedlings are organized into batches, labeled, and prepared for delivery to the farms. This early selection prevents growers from spending months caring for plants that are unlikely to reach full productivity. In high-precision agriculture, poor performance is not discovered at the end of the season. It is identified and removed as early as possible. Before the seedlings arrive, the greenhouse must be completely prepared. Strong structural frames are built to withstand desert winds and harsh environmental conditions. The greenhouse covering reduces the impact of outside temperatures, limits the entry of harmful insects, and creates an internal environment that can be controlled. Inside the greenhouse, workers install the drip irrigation lines, water pipes, sensors, cables, ventilation systems, and control equipment. Above every row of plants is a suspended support system. Long strings are lowered from overhead structures, ready to guide the tomato plants as they grow upward. The walking paths are also carefully planned. They must provide enough space for workers, carts, maintenance equipment, and automated transport systems to move between the rows. At the same time, the young plants are transported from the nursery in specialized trays. They must remain properly hydrated, protected from excessive heat, and stable during transport. Each batch is inspected one final time before entering the greenhouse. Planting density, spacing, irrigation schedules, and expected harvesting dates have already been calculated. There is no room for random placement. Everything must be ready before the first seedling enters the growing area. The seedlings are placed into carefully prepared rows. Depending on the production system, they may be planted in treated soil or in specialized growing bags filled with a controlled substrate. Each plant is positioned at a precise distance so that the leaves receive enough light and air can circulate freely. Immediately after planting, the drip irrigation system begins operating. Water is not spread across the entire surface of the greenhouse. Instead, it moves through small pipes and is delivered directly to the root zone. Nutrients are mixed into the irrigation water according to the needs of the crop. Sensors monitor moisture levels, temperature, and water absorption. On hotter days, the system may increase the number of irrigation cycles. If the root zone remains sufficiently moist, the system reduces the amount of water being delivered. This prevents unnecessary evaporation and avoids waste. In a desert environment, careless irrigation can destroy an entire crop. For that reason, every drop must reach the right place at the right time. The lesson is simple. Successful desert farming is not about using more water. It is about using water with greater intelligence. As the plants begin to grow rapidly, maintenance becomes a continuous process. Side shoots that emerge between the main stem and the leaves are removed so that the plant does not waste energy on unnecessary branches. Old leaves, damaged leaves, and leaves blocking light are also cut away. The goal is to keep the canopy open, improve airflow, and direct the plant's energy toward the main stem, flowers, and fruit. When flowering begins, every cluster is observed carefully. A plant carrying too many flowers does not always produce a better harvest. If it is forced to support too many fruits, the tomatoes may remain small, develop unevenly, or fail to reach market quality. Workers therefore evaluate the strength of each plant, the number of flowers, and its ability to support future fruit. In many greenhouses, bee colonies are introduced to improve pollination. The bees move from flower to flower, creating vibrations that help release pollen. This increases fruit set and improves uniformity. Even in a greenhouse filled with sensors, machines, and software, nature still performs an essential task. Advanced agriculture does not always replace natural systems. Sometimes it understands them, supports them, and uses them more effectively. Tomato plants inside these greenhouses are not allowed to spread freely across the ground. Their main stems are trained upward using the hanging support strings. Workers gently wrap the stems around the strings or attach them with specialized clips. This process must be repeated regularly because the plants continue growing higher. If a plant is not guided properly, it may lean, break, or collapse into the neighboring row. The support system allows each plant to use vertical space. This makes it possible to increase production per square meter while still maintaining light exposure and airflow. As the flowering stage progresses, small green tomatoes begin to appear. From this moment onward, the plants require even closer attention. Workers inspect every cluster, observing fruit size, color, shape, and growth rate. Small, damaged, poorly formed, or badly positioned fruits are removed. At first, removing fruit may look wasteful, but if every fruit remains on the plant, the available nutrients are divided among too many developing tomatoes. As a result, the entire cluster may become smaller, less uniform, and less valuable. Fruit thinning allows the plant to direct its energy toward the strongest tomatoes. At the same time, water and nutrition are adjusted again. The needs of a fruiting plant are different from those of a young seedling. Minerals such as potassium and calcium must be managed carefully to support fruit firmness, color development, and resistance to cracking. Farm managers do not rely only on visual inspection. They monitor moisture, nutrient concentration, greenhouse temperature, root zone conditions, and growth speed. If plants grow too rapidly, their stems can become weak. If they grow too slowly, the harvest schedule and total yield may suffer. Everything must remain balanced. This is why farming in the Irrigation Valley is closer to operating a biological factory than to traditional field agriculture. Every tomato plant is a living production line, and every part of that line must function correctly. At this point, ask yourself which part of the system has surprised you most: the water network, the grafting technology, the greenhouse design, or the automated controls? Share your answer in the comments, because each one is essential to making this entire desert operation possible. As the plants enter their strongest growth period, the entire greenhouse is inspected continuously. Sensors record air temperature, humidity, sunlight, nutrient conditions, and moisture levels around the roots. Computer systems collect this data and help farm managers identify areas that may be receiving too little water, experiencing abnormal temperatures, or developing more slowly than expected. Workers move through the rows, checking leaves, stems, flowers, and fruit. They search for early signs of pests, disease, nutrient deficiency, or physical damage. When a small problem is detected, it can be addressed before it spreads throughout the greenhouse. The tomato clusters continue increasing in size. Their deep green color slowly becomes lighter. Then, the first yellow and red tones begin to appear. This is the signal that the harvest is approaching. When the tomatoes begin to ripen, harvesting is organized by section. Not every fruit on every plant reaches maturity at the same time. Harvesters must select tomatoes with the correct color, size, firmness, and stage of ripeness. If a tomato is harvested too early, it may not develop its full flavor. If it remains on the plant too long, it can soften, crack, or become damaged during transport. Every cluster is therefore checked visually and by hand. Tomatoes that meet the required standards are picked carefully to protect their skin and shape. They are placed into specialized trays or containers. Inside modern farms, carts, and automated transport platforms move along the greenhouse rows. Workers do not need to carry heavy containers across long distances. They can focus on selection and harvesting. Once a tray is full, the transport system carries it toward the collection area. This reduces physical labor, increases speed, and limits damage to the fruit. On some farms, harvesting data is recorded for each row. Managers can compare which areas produce the highest yields, which varieties generate the most marketable fruit, and which harvesting period provides the best quality. That information is then used to improve the next production cycle. Freshly harvested tomatoes must move quickly into the sorting and packaging process. The longer they remain exposed, the greater the risk of moisture loss, softening, and declining quality. For that reason, harvesting, collection, and transportation are organized as one continuous operation. From the harvesting area, tomatoes are transported to a sorting center. The trays are placed onto conveyor belts, where leaves, loose stems, and debris are removed. The tomatoes then pass through systems that evaluate size, weight, color, shape, and surface quality. Tomatoes, meeting the required standards, are separated into groups according to size and intended use. Part of the harvest is packaged for sale as fresh produce. Another significant portion is directed into processing lines to improve storage efficiency, simplify long-distance transportation, and support large-scale distribution. This does not mean that processing plants receive inferior tomatoes. Tomatoes intended for processing must still meet strict requirements for ripeness, raw material quality, and food safety. Processing is a planned production strategy, not a way to dispose of unacceptable fruit. Fresh market tomatoes are placed into trays or packaged by weight. Some varieties remain attached to the vine, while others are packed individually. Each package receives labels showing origin, packing date, and production batch information. The finished packages are placed into larger transport boxes and prepared for supermarkets, restaurants, and distribution centers. With a large national tomato output, relying only on fresh consumption would place enormous pressure on refrigerated storage, transport speed, and supply chain coordination. Fresh tomatoes have a limited shelf life. They are vulnerable to pressure, impact, heat, and moisture loss. Processing part of the harvest into tomato paste, sauces, canned products, and other packaged foods increases shelf life and creates products that are easier to export. According to the figures used in this video, Israel produces approximately 300,000 tons of tomatoes each year on around 2,400 hectares of land, involving roughly 400 farms. What makes this remarkable is not only the total volume, it is the fact that this production is achieved under severe water limitations, restricted land availability, and some of the most difficult agricultural conditions in the region. Instead of expanding farmland without limits, Israel focuses on increasing the value produced by every square meter and every tomato. Because the production volume is so large, a major portion of tomatoes meeting processing standards is transported directly to industrial facilities. This stage improves preservation, transport efficiency, export potential, and product convenience. Compared with fresh tomatoes, processed products can be stored for longer periods, packed more efficiently, and shipped across greater distances. At the factory, tomatoes are unloaded into the receiving system and transported toward large washing tanks. Water movement and mechanical agitation remove dust, sand, and other surface contaminants. After washing, the tomatoes pass through an inspection system. Any fruit that has been seriously damaged during transport or fails food safety requirements is removed from the line. The approved raw material continues into cleaning and sanitation stages. Some facilities use light-based systems or other surface treatment technologies to reduce microorganisms before the tomatoes enter the deeper processing area. The tomatoes are then moved into cutting and crushing machines. Rotating blades break down the fruit and create a uniform mixture. Depending on the final product, the factory may separate the skin and seeds or retain certain components to create a specific texture. The crushed tomato mixture is pumped through enclosed pipes into large cooking tanks. Temperature, cooking time, and concentration are monitored carefully. Heating softens the material, reduces excess water, develops flavor, and creates the thickness required for tomato paste or sauce. If the temperature becomes too high, the product may burn, darken, or lose quality. If the temperature remains too low, the mixture may fail to reach the correct consistency or food safety standard. Sensors therefore monitor the process continuously. Once the mixture reaches the required concentration, the seasoning stage begins. Salt, sugar, vinegar, and other ingredients are added according to a predetermined formula. Every ingredient is measured precisely. A factory cannot depend on personal judgment or guesswork. A bottle produced today must taste almost identical to a bottle produced several months later. Consistency is essential for building consumer trust and meeting international quality standards. When the sauce reaches the correct specification, it moves toward the filling line. Empty bottles and jars enter in organized rows. Automated nozzles dispense a precise amount into every container. The caps are then applied and sealed immediately. Production dates, expiration dates, and batch codes are printed onto the packaging. Sensors inspect the containers for incorrect filling levels, damaged bottles, faulty seals, or loose caps. Any product that does not meet the required standard is automatically removed from the line. Approved bottles are labeled, packed into boxes, stacked, and transferred into storage. From tomatoes grown in the desert, the product has now become tomato paste, ketchup, sauce, or canned food that can be preserved, transported, and exported efficiently. This is how Israel increases the value of agricultural production. It does not focus only on growing more tomatoes. It builds an entire chain that connects water, energy, seeds, greenhouses, harvesting, packaging, processing, storage, and international distribution. If you have watched this far, subscribe to the channel and share this video with someone who believes deserts can never become productive farmland. The Arava Valley proves that the real limitation is often not the land itself, but the system built around it. At the family dinner table, tomatoes appear in fresh salad, tomato sauce, and beside a plate of French fries. Few people think about the enormous system behind such an ordinary meal. Desalination plants, water pipelines, solar farms, greenhouses, seedling centers, automated equipment, packing facilities, and food processing factories. The Arava Valley did not become productive by accident. Israel transformed it through science, infrastructure, precision, and long-term discipline. When water was scarce, they created a new water supply. When sunlight was overwhelming, they converted it into energy. When the land was too dry, they built a controlled environment where plants could survive and thrive. Weak people look at a desert and say nothing can be done. Capable people look at the same desert and begin designing the entire system.